Hello student, welcome to this lesson on concentration and dilution. As we had explained earlier, concentration of a solution is the amount of solute contained in a given volume of a solution. To make the concept clear, we are going to use some examples. In an experiment, 0.4 grams of sodium hydroxide solute were dissolved in 100 centimeters cubed of distilled water, then made up to 200 centimeters cubed of solution by adding enough distilled water. Calculate the concentration of this solution in grams, B in moles. The first part, we are already given the number of grams, so we don't need to change because the first question is asking about grams of the concentration. So it will be 0.4 grams per 200 centimeters cubed of solution, so because it was made up to 200, so don't use 100 centimeters cubed. In part B, in moles, it is computed as follows. Remember, the molar mass of sodium hydroxide is 40 grams. 23 plus 16 plus 1, you get 40 grams. So what about 0.7 grams? You do a cross multiplication and you get your answer as 0.01 moles. These ones are in 200 centimeters cubed of solution. So that is the concentration. Example 2, suppose 5.6 grams of potassium hydroxide were dissolved in 400 centimeters cubed of distilled water, then made up to 700 of solution. Determine the concentration in grams, then in moles. In the first part, the number of grams in 700 is 5.6. Also, it can also be expressed in 1,000 by doing this cross multiplication, and you get your answer as shown in your screen, 8 grams per diameter cubed. In moles, what we need to do is we want to convert 5.6 grams into moles. We know 1 molar mass of potassium hydroxide is 56 grams. So what about 5.6? Do cross multiplication, divide by that, you get your answer as 0.1 moles in 700. That is the concentration in 700 centimeters cubed of solution. If you want to change this one into 1,000, you put the 1,000 below here, then you do a cross multiplication and you get your answer as 0.14 moles per liter. So the two answers are okay. Dilution is a process by which concentration of a solution is lowered by adding more solvent into the solution, like adding water. During dilution, the amount of solute remains the same, does not change as the volume of the solution increases. So the solute do not change, but the volume changes. As an example, calculate the volume of 4 molarity of sulfuric acid solution that will be required to make 200 centimeters cubed solution of 0.5 molarity of sulfuric acid. Here, we need to first of all work with this one because we have provided the molarity and also the volume. But we know 0.05 m stands for 0.5 moles in 1,000. What about in 200 centimeters cubed? So you do a cross multiplication, then you get the number of moles will be 0.01 moles of 0.5 molarity of sulfuric acid. Now this is the number of moles that we are going to transfer to the first part where being asked about the volume, so that we know how much of this do we need, the volume. So how do you do it? The interpretation of this is 4 moles in 1,000. So what about in 0.01 moles? So you put the moles on one side, then you do a cross multiplication, and you get your answer to be 2.5 centimeters cubed. Another example, a volume of 20 centimeters cubed of ethanoic acid, the formula is given, was diluted to 500 centimeters cubed of solution. Calculate the concentration of the solution in A, grams per liter, B, in moles per liter. These are the RAM of the element carbon, hydrogen, and oxygen. Density of ethanoic acid is 1.05 grams per centimeters cubed. Solution. In this question, we are not provided with a mass, so we need to establish the mass of ethanoic acid, and this one we are going to use the relationship mass is equals to density times volume. Therefore, mass of ethanoic acid will be density, which is 1.05 gram per centimeters cubed, already given. You multiply by 20 centimeters cubed. This is the volume of the ethanoic acid. You'll get your mass as 21 grams. So these grams are present in 500 because it was diluted to 500 or made up to 500. So what about in 1 liter? Because we want our grams per liter. So it will be given this relationship, 21 grams are present in 500 centimeters cubed. What about in 1 liter or 1000 centimeters cubed? Quick cross multiplication, you divide by this one and you get your answer as 42 grams. So 42 grams per liter is the answer for the part 1. The second part, density is mass over volume. So we want to establish now the mass. So you say mass is equals to density times volume. Therefore, the mass still remains the same, 21 grams. So 1 mole has 60 grams because now we want to change this mass into moles. So what about 21 grams? You do a cross multiplication, 21 times 1 divide by 60, you get 0.35 moles. These moles are present in 500. Now we ask ourselves, what about in 1000, so that we can get the moles per liter. So this we multiply, then you divide by that, you get your answer as 0.7 m, molarity of 0.7. That example, a bottle containing sulfuric 6 acid has the following information: density 1.800 grams per centimeters cubed, percentage purity 98%, relative formula mass 98 grams. Calculate the concentration of sulfuric 6 acid in moles per liter. Then B, determine the volume concentrated of the concentrated sulfuric acid that should be diluted to produce 2 liters of 2.5 molarity sulfuric 6 acid. This is how you work out this. You have been given the purity and also the mass and also the density. So here we need first of all to establish the mass of this sulfuric acid, and we are going to consider in 1000 centimeters cubed because our calculation will be done in per liter. So this one is per liter and then the other one will be calculated that way. So we ask ourselves, what is the mass if the volume is 1000? So mass is equals to density times volume. You get a mass of 1800 grams of sulfuric 6 acid. But we were given the purity of 98%. So if you got this one, you multiply by 98% to get 1764 grams of pure sulfuric 6 acid. So the concentration in moles per liter or molarity, we say 1 mole has a molar mass of 98 grams. So what about 1764 grams? You multiply by 1, then divide by that, you're going to get your answer as 18 moles in 1,000 centimeters cubed, because we use a volume of 1,000. Therefore, this translates to 18 molarity. Part B, determine the volume of concentrated sulfuric acid that should be diluted to produce 2 liters of 1.8 m sulfuric 6 acid. So the interpretation of this 1.8 moles in 1,000. So what about in 2 liters? The 2 liters will be 2,000 centimeters cubed. You multiply and then divide by 1,000, and your answer will be 3.6 moles. Now we remember the concentration of the concentrated sulfuric acid was 18 molarity from A above. This meant that 18 moles in 1,000 centimeters cubed. Therefore, what about 3.6, so that we can get the volume? So we put the moles on one mole side, and then we multiply, then divide by 18. You get your answer as 200 centimeters cubed of the concentrated sulfuric acid that will be required to produce 2 liters of 1.8 molarity of sulfuric 6 acid. Thank you, and here is a quiz for you. Attempt all the 3 questions and the answers are provided. Don't work from the answers, quiz yourself. Thank you, bye bye, and let's meet in the next lesson.